Hi all, welcome back. Today we are going to discuss about one-way ANOVA analysis in SAS, and we are going to cover the three versions of it. One is the classic parametric F test, the second one is Welch ANOVA for unequal variances, and the third one is non-parametric test, which is Kruskal-Wallis Test. We will explore the theory, the SAS code, and most importantly how to interpret your result step by step. So one-way ANOVA analysis test is conducted to identify whether the means of three or more groups are significantly different or not. So let's say, for example, we want to compare the average weight of fish across the species. So in this particular case, our hypothesis is going to be all species have the same mean weight, whereas our alternate hypothesis is at least one species mean differs. We are going to work on the SAS help fish dataset, where our independent variable is going to be species, which is a categorical variable, and the response variable is weight. Let's see how our data looks like. PROC print data equal to SAS help dot fish. Let's look at the top 10 records. Run. And as you can see here, species, which is a categorical variable, and it is going to have different species of fish, whereas weight, which is a response variable, and it is a numerical data type. Let us look at some of the properties of our response variable, that is weight. So I'm using PROC univariate here to see how our response variable looks like, that is weight. Weight, histogram, weight, normal, mu equal to estimate, sigma equal to estimate. Let us draw the kernel density plot too. Title, distribution of weight variable. Run the code. And as you can see here, we have got some descriptive analytics of weight variables, such as number of records are there, 158, mean is 399 approximately, standard deviation is 359, skewness is 1.09. What is we are interested in? We are interested into the distribution of the weight variable, and you can see here the weight is not normally distributed. And if you would like to see how we can say that, you can see here the KS test, which is less than 0.05. Hence we can say that our weight variable is not normally distributed. That is one thing. Let us use PROC means procedure data equal to SAS help dot fish. We will be using class statement on species. Variable is going to be weight, and let's run the code. By using the PROC means procedure, you can see for each and every species, you can see here the number of records, n, which gives you the number of non-missing value records. So for bream, there is a one missing value, and you can also see here the mean value standard deviation for each and every species type. Let's conduct the parametric ANOVA analysis using PROC GLM procedure. But before that, you have to keep certain assumptions in mind, that your data should be normally distributed, homogeneity of variance should be met, your dependent variable type is going to be either interval or ratio data type, and your independent variable is going to be a categorical data type, and the observation within and between group must be independent of one another. Now let's start with the code. PROC GLM data equal to SAS help dot fish. Class, here I am going to define our independent variable, which is the species. Model weight equal to species, means species, Tukey CLTIFF. Now this code fits a one-way ANOVA model where weight is the dependent variable and species is the factor. The Tukey CLTIFF option requests post-hoc Tukey test with the confidence interval. Now let's run the code, and you can see here this is an output which has been generated from the GLM procedure. There are 7 species type, and you can see which of them are there: bream, parky, perch, pike, PROC, smelt and whitefish. Number of the observation rates are 159. As you remember, there was one missing data for weight variable for bream, and that is why 158 observations are used. And you can see here the model is, for model, degree of freedom is 6, sum of square, mean square and F value is 15.10, and this is the value which we are interested in. Since P value is less than 0.05, hence we can say that one fish species weight must be significantly different from the 6 others. Now let us look at the box plot which has been generated by the GLM procedure. You can see smelt has the lowest mean weight, whereas you can see for pike it seems the mean weight was the highest, must be over 600. What we are interested in it is the Tukey test, which provides us the comparison between different species type and what is the difference between the mean value for their weight. Means difference here is the difference between the group means. For example, pike means weight minus roach means weight, and you can see the significant 95% confidence limit range. Now if let's take this case, if the interval includes 0, the difference is not significant, whereas if the interval does not include 0, either it is above or below 0, it means it is significant. And as you can also see here, PROC GLM procedure also puts up the stars here. It means that this species comparison mean weight is significantly different from each other, and there are various species comparison you can see which are significantly different from each other. For example, pike versus perch, pike versus roach, pike versus parky. So in this particular way, one can conduct the ANOVA analysis, and one-way ANOVA indicates significant difference in the mean fish weight across different species. And Tukey's HSD Post-Hoc Test revealed that pike had significantly higher mean weight than roach and perch, while perch and roach did not differ significantly. In this particular way, one can conduct the ANOVA analysis, and by the help of the Tukey's test, you can see which of the species or various categories have different comparison if you are using any other data set, and find out which of them are significantly different from each other. Now let's continue with Welch ANOVA analysis. The Welch ANOVA is a robust alternative when group variances are unequal and data is almost normally distributed. It adjusts the degree of freedom to handle the heterogeneity. In SAS, we can do this using PROC GLM procedure with the Welch option. Let's see how we can do that. I will copy and paste this code, and in place of Tukey and CLTIFF, I will replace it with Welch options, and that's it. Let's run the code. Here the Welch option performs Welch F test. SAS outputs both the traditional ANOVA F test, so here it is the traditional ANOVA F test, and the Welch test. So this is what we are interested in. This is the Welch test, and you can compare them. If Levene's test was significant, rely on the Welch p value instead of the regular one. So look for the row level Welch ANOVA or Welch test for unequal variance in the output, and since p value is less than 0.05, at least one group mean differs even with the unequal variances. So this way one can conduct Welch ANOVA analysis using PROC GLM procedure in SAS. In the beginning of this session, I have discussed about certain assumptions when you are conducting an ANOVA analysis, and that is normality of the data should be there, homogeneity of the variance should be there, observation should be independent of one another, and the dependent variable should be a continuous variable. We know that our observations for fish data set are independent of each other, and we know our dependent variable is a continuous data type, which is weight variable. So before we will continue with the ANOVA analysis, we should always check for normality and the homogeneity of the variance also. Now before we proceed further, we will check all these assumptions, and on the basis of that we will decide whether we have to go with the classic F test or with the ANOVA analysis, or we have to go with the Kruskal-Wallis Test, which is a non-parametric ANOVA analysis. So for that, I am going to conduct a Levene's analysis to verify whether there is a homogeneity of variance or not. By the way, I have already recorded a session on Levene's test in greater detail. You can watch that particular video. I'll put up a link in this particular session. So I'm just going to conduct the Levene's test, not going to talk about the theory and the other part. Levene's test for homogeneity of variances. The procedure is again very simple. I'll copy this piece of code and I'll change the options here. Hove test equal to Levene. That's it. Let's run the code. What we are interested in: Levene's test for homogeneity of variance. Since the p-value is less than 0.05, hence it confirms that our data points does not follow the homogeneity of variance. We should conduct the Welch ANOVA test. But before we should perform that, we also need to verify that whether our data is normally distributed or not. And for that, I'll copy and paste this piece of code. Ideally, we should do it for each and every category, but our data points are less, so it won't make much of the sense, and that is why I'm doing it on overall weight variable. Otherwise, you can use here class species, and then you should run the univariate analysis and look for the KS analysis. But since the data points for each and every category, for each and every species here are less than 30, I am running the univariate procedure on the whole data set. Let's run the code. So one thing, as I had mentioned earlier, the distribution is right-tailed, data is not looking normally distributed, and KS test confirms it since the p-value is less than 0.05, hence the data is not normally distributed. So fish data set weight variable for different species type does not follow the homogeneity of variances, as well as it is not normally distributed. Hence we will go with the Kruskal-Wallis test, which is a non-parametric ANOVA analysis. And in SAS we can use PROC n-par one-way procedure to conduct the Kruskal-Wallis test. Let's see how we can do that. PROC n-par one-way data equal to SAS help dot fish, and then you have to use the option Wilcoxon. Class species var weight run. So in this code, the Wilcoxon option automatically runs the Kruskal-Wallis test when there are more than 2 groups. Let's run the code and see how the output looks like. The output provides a chi-square statistics and a p-value. If p-value is less than 0.05, at least one group distribution differs. So here you can see the Kruskal-Wallis test. It provides you the chi-square values, and you can see that since the p-value is less than 0.05, hence we can confirm that at least one group distribution differs from another one. And this is how one can conduct the non-parametric one-way ANOVA analysis in SAS using PROC n power 1 way in SAS. If you have to conduct one-way ANOVA analysis, here is how you should be doing that. If your data is normally distributed and equality of variance is there, then go with the classic F test. If the data is normally distributed but homogeneity of variance is not there, then go with Welch ANOVA. If none of these assumptions are met, then go with the non-parametric test, that is Kruskal-Wallis test. And that's a wrap on one-way ANOVA analysis from parametric to robust to non-parametric method. So that's it for today, guys. Thanks for watching and have a great day.